is a linear demand equation. That is the statement of a demand curve mathematically. But it's a linear demand curve. It's a straight line. It's not wiggly wavy. Okay? It still illustrates all the principles we would want to use. The linear demand curve is expressed up here. And drop down a little bit for the second line. Quantity demanded of good X. These are my notations, my abbreviations. The quantity that people will buy of good X, let's say we're selling good X, has been determined to depend on some other variables out here. The price we charge for our product, the price of X. The price that people are charging for product Y in some way impacts our sales. Same is true for product Z. Whatever price is being charged for that impacts our sales. Plus M here stands for income. Plus A, the amount of money we spend on advertising. This is a really short, sweet, simple demand equation. It's only got 5 variables in it. In the real world, you could have a demand equation with 15 or 20 variables in it. That typically you and I are not going out and building this. We're hiring some research firm, some econometric firm to go out into the market, some marketing research firm, and determine this for us based on our history of sales over the last year, 2 years, 5 years. And so they would be looking at the behavior of all of these variables, putting it all together into an econometric statistical model, multiple regression, and trying to figure out just how powerful these forces were on our sales. So they give us this equation, the equation in white. We've already seen the variables that are going to be at work. Price of Y, price of Z, income, advertising. The important thing to us as we start playing with this equation is the coefficient in front of each variable. And the coefficient is designated as alpha for that variable. Alpha means the coefficient. So the coefficient for the price of X is negative 20. We're going to be using that over here in a minute. The coefficient for the price of Y is a positive 17. Positive 17. Coefficient for the price of Z is a negative 8.5. Coefficient for income is a positive 0.002. And the coefficient for advertising is a positive 1.6.
The fish thing or whatever.
Alpha. That's the symbol alpha. Greek letter alpha.
Okay.
Okay. If you'll let me take this coefficient and abbreviate it with alpha, I can give you a standard formula you'll use on all the applications for this thing. Okay. Important to notice the sign as well as the number. The sign of the coefficient is critical. This one's a negative, a positive, a negative, a positive, a positive. Watch that sign. To jump ahead just for a moment, okay? We have a negative sign in front of the price of X. That means that the amount of X people buy is negatively related to the price of X. Does that make sense? Inversely related. It means when the price is high, they don't buy as much. And when the price falls down, they buy more. Well, that's the law of demand. The cheaper we sell it for, the more people buy it. That's an inverse or negative relationship. But look over here for good Y. When the price of Y goes up, it's multiplied by 17 and added to our sales. So when the price of Y goes up, we sell more X. Think back to microeconomics. What kind of goods would those be?
Substitutes.
They are substitutes or substitutes in consumption. Think of Coke and Pepsi. If the price of Pepsi goes up, the Coca-Cola dealers sell more Coca-Cola. So a positive sign in front of the price of some good indicates these goods, Y and X, are substitutes. The next one, Z. Z has a negative coefficient. So if the price of Z goes up, the value of Q goes down. That would indicate complements. That if this were flashlights and batteries, Now, when the price of batteries, let's say, rises, we sell fewer flashlights because it's too expensive to buy the two of them together. So a negative coefficient in front of PZ tells us those are complements. What about a positive sign in front of income? What happens to our sales, X, when incomes rise, based on this sign?
They go up.
They go up.
So it's normal.
So it's a normal good. And then finally, we better find this kind of sign here, mine, for advertising. I'd hate to think that if we spent more on advertising and our sales went down, we'd really be in trouble then, right? We'd sort of screw with that advertising program. So the signs are important to us. Once we see all that, what we're going to be playing games with is the different elasticities or the different magnitude of effect changes in these variables have on our sales. What we're going to do is we're going to, on that demand curve for our product, we're going to identify a particular point that occurs at a given price. And we're going to start asking, well, what happens if things change from here? The price we're going to identify, and let me make sure I'm staying with my notes, we're going to be asking what happens when we charge a price of $16 per unit, and at the same time we know that the price being charged for Y is 4, price of Z is 12, incomes in our market are $18,000, let's say per capita, per person, and that we're spending $100 per unit, we're buying 6 units of advertising. $600 in advertising. But 6 units. What we're going to do is we're going to take these numbers, we're going to plug them all back into the equation, and we're going to calculate the value of Q. So we'll be saying, at a price of $16, given these variables, how much will we be selling? This will be QD of X, quantity people buy of our product. All right? So go ahead. Plug the numbers back in. Plug in 4 and 12 and, well, this one, that's 16. I'm off balance. That's going to be 16. That's going to be 4. That's going to be 12. Incomes are going to be 18,000. And A is going to be 6 units. Plug those numbers back in and crank through that equation and tell me what you get.